Trapezoids today. So if you remember from the quadrilateral hierarchy, right at the top we had quadrilateral and then we split into kind of two branches. One branch was kites, which we talked about yesterday. And then we learned that kites also includes rhombuses and squares. And then the other side was kind of the trapezoid side. And they all come back together with squares at the end. So that's why we sort of looked at kites and trapezoids, and then we talk about all the different special kinds of them. Go ahead, Caleb. Sure.
How come for like in quadratos, how come there's like so many different shapes that are just named?
Because they just have a lot of different special, you can make sides parallel, you can make sides congruent, and every time you change one of the properties, you change the definition of the figure, you change it, and they all have different properties, but it's kind of cool, and I mean, we really just kind of skim the surface here. If you take like a real high-level geometry class, you start looking at like all of the things that these shapes have in common or don't have in common, and why this shape fits into this category, and yeah, there's a lot of relationships that come out of quadrilaterals. So we do spend a lot of time on quadrilaterals, and then we kind of just throw all the other polygons into triangles, and quadrilaterals are the big ones in geometry, and then everything else is just kind of like
How come there's
right.
not like hexagons?
Because they just don't have the special properties that quadrilaterals can have.
Oh,
so
they're always 100 degrees.
Right. All right, so trapezoid, write this down. The definition of trapezoid is a quadrilateral with at least one pair of parallel sides. That's the big thing to get out of this, at least one pair of parallel sides.
Like a square.
Okay. Well, a square has at least one pair, so a square is a type of trapezoid. Yeah, but to be a trapezoid, you only have to have one pair. Sometimes you have two, but you only have to have one. So in this figure, like this side and this side would be parallel to each other, but you can see that this side and this side are not. Okay, so to be a trapezoid, they could be, and that's a different kind of trapezoid. We're going to talk about that in a minute too. But to be a trapezoid, all you have to have is one set of sides that's parallel. Okay, those sides that are those sides that are parallel are called the bases of the trapezoid, and this gets confusing, and it's going to. I mean, it's not too bad right now, but when we get to area, and we start talking about area of a trapezoid, and you have to tell the difference between the bases. A trapezoid has two bases, and that's confusing for people, because you're used to thinking of base as being the one on the bottom, okay? But, like for this trapezoid, this and this would both be called the base of the trapezoid. Okay, so the bases are your sides that are parallel. Okay, and I marked those for you there. That's what I have there in green, that's the... those are your bases. Up there. So let's talk about, because Caleb mentioned something a minute ago. He said, I think those other sides are congruent. If those other sides are congruent, that's what's called an isosceles trapezoid. So it's got to have one pair of parallel sides to be a trapezoid. If the other sides, so the ones that are not parallel, are also congruent, that's what's called an isosceles trapezoid. And that's easy to remember because hopefully you remember isosceles triangles from when we did our triangles unit. And in an isosceles triangle, you had these two sides congruent to each other. In an isosceles trapezoid, it would be like these two sides that are congruent to each other. Okay.
Does that mean that a rectangle can be an isosceles trapezoid?
Yep, a rectangle is a type of isosceles trapezoid. Because in a rectangle, and I think we come to that later, but since you brought it up here, this side and this side are parallel, and this side and this side are congruent, right? So that makes it an isosceles trapezoid. Now, it just so happens that these sides are also congruent, and these sides are also parallel. But it does fit the criteria for an isosceles trapezoid. Okay, what's that? Yep. Two bases for any type of trapezoid would technically have two bases. Yeah, you could call either one of them the bases. Now, I would name them in pairs. So I would say like this and this are the bases, or this and this are the bases. I wouldn't just say all four of them are bases. Kind of depends on how you're looking at it. Caleb?
Just wondering, you know how like you label like congruent sides with a mark? Do you label parallel sides with like putting a line through them?
See this like arrowhead here? Kind of hard to tell because my pointer's red, but that little arrowhead is the marking for parallel.
Okay.
Okay? Oh, and I gave you another picture of an isosceles trapezoid down there, but we already had marked that up there. Okay, so parallel lines. We've learned a lot about parallel lines already this year, right? All the stuff with like the corresponding angles and the alternate interior angles, that was all parallel line stuff. And look, a trapezoid happens to have two parallel lines. So if you extend the bases, so see what I did here is I extended these bases and then I just extended this line DA, so I kind of traced over them and then traced this line. I want to know, what do I call this pair of angles, angle A and angle D? I want everyone to think for a minute. Do you at least recognize that parallel line picture?
Yeah.
Yes.
Okay. Rachel, what do you think?
Same side interior.
That's right, they are. Yeah, I'll get it there. So A and D are same side interior angles. Okay, SSIA is how we abbreviate that. Same side interior angles. What do we know about same side interior angles? Matt?
They're supplementary.
They're supplementary, yeah. And what does supplementary mean again?
They both add up to 180.
That's right, they're going to add up to 180. You don't necessarily have to write that, the scribbles there down, because it's going to come up in just a second, but I wanted you guys to kind of generate that. We have a theorem called the trapezoid angle theorem. Consecutive angles between a pair of parallel sides, which sounds confusing, but when you look at it in the picture, it makes sense. Those angles are supplementary, okay? So, like this angle and this angle are not supplementary, but the ones that are between the bases, this one and this one, like D and A, those angles have to be supplementary. What about B and C? Jackson?
That's the same thing.
They'd also have to be supplementary, right? So these are supplementary and these are supplementary. Okay, your pairs that are between those parallel sides. Because we've already talked about the same side interior angles being supplementary. Okay.
What does the suffix, like, the whole mentary part mean?
I don't know what that suffix means specifically.
Supplementary has it, and so does elementary.
I'll have to look that up.
And those are nothing alike.
Yeah, I'm not sure. Good question. I'll look that up. Good? Still writing? A couple people still writing? Okay. Lines of symmetry in a trapezoid. Do we have any? So this one here on the right, this is just a regular trapezoid. Can you find a line of symmetry anywhere? Jackson?
The one on the right is in between the midpoint of the two bases. If it's an
So,
isosceles trapezoid.
If it's an isosceles trapezoid, right. So this one is not isosceles. This one has no lines of symmetry. Okay, none here.
Yeah, you said the one on the right.
Okay. Oh, you're right, I did. I meant the left. I apologize. Yep, I meant the one on the left, because I know my right from my left. That's awesome. Yeah, one on the left, no lines of symmetry. One on the right, Jackson's right, there is a line of symmetry here. Are there any others?
No.
Okay, if that green line is a line of symmetry, what do I know about this angle and this angle? They would have to be congruent, right? And this angle and this angle would have to be congruent, okay? Because that line of symmetry means I should be able to fold this over to this, okay? In a regular, just no frills trapezoid, just a base trapezoid, no lines of symmetry, so you don't necessarily have congruent angles, okay? But in an isosceles trapezoid, you do. You guys are all having way more fun looking at the snow than looking at trapezoids. I don't know that I can blame you, but no, we cannot open the window.
Why not?
He walked from the middle school in a no-sleeve shirt.
Okay, so we just said that on that last slide. Okay, guys, pull it in. We're almost done. We already said, what do we know about angles A and B? Well, if there's a line of symmetry, A would have to be congruent to B, right? And C would have to be congruent to D. Okay, so we know A, this is if it's an isosceles trapezoid. You have to know, oh, did I put a, okay. So this is just, the words up there on top are just describing where that line of symmetry is. It's the perpendicular bisector which Jackson pointed out that it was through the midpoints. It's also perpendicular to the midpoints. Okay, so that line that I just drew would make a right angle here. Okay, and since it's a line of symmetry, these angles and these angles would have to be congruent. Okay, and then what else do we know? What do we know about angles A and C? They're supplementary, right? Hi.
Are you willing to pick up Jasper for me tonight?
Yeah, I can do that.
I just worried about the roads.
Yeah.
I get home before dinner.
Yeah, no, I can do that.
Okay,
Sure.
I'll change it on my sheet.
All right, thank you. Train of thought. Okay, so we know A and B are congruent. We know C and D are congruent. We also know that A and C are supplementary and B and D are supplementary. So in an isosceles trapezoid, I can give you one of the angle measures and you can find all the other ones. Okay? Because you can subtract from 180 to get this one, and then you know this is congruent over here and this is congruent over here. Okay, Jake?
Okay, this might sound really stupid.
No,
but
never.
Can you please tell me, like, I kind of just didn't hear what you were saying. Can you just tell me what the top part means? Like,
Okay, this is just describing, that's okay, this is describing where this line of symmetry is located. Probably the picture makes way more sense than the words. Okay, so this is saying the perpendicular bisector of the base is so if I have this base, AB, and I draw the perpendicular bisector, okay, I know that same line is going to be a perpendicular bisector down here. Okay, and that's my line of symmetry. So if I draw this line and I know it makes a right angle, then I know for sure this makes a right angle also. Okay, and these would be equal to each other and these little guys would be equal to each other. Okay, so that's really just describing where that line of symmetry is. I bet most of you, I could hand you the picture of an isosceles trapezoid and you could say, oh, line of symmetry is right here. Okay, so you don't need to know those. I would not put a whole lot of brain power into those words. Okay, and, oh, look, that's a nicer version of all the scribbles that I just put on there. Okay, so yeah, so when you draw that line, it makes a right angle, okay, with the two bases, and it cuts the sides, so it cuts this and this in half, cuts this and this in half, and then it also means that A and B are equal, C and D are equal of lines of symmetry. I'm going to move this up so you can copy this down. Look at this. I-T-B-A-T. Does that sound familiar?
Yeah.
Like it-bat, right? Except instead of isosceles triangle, this time it's isosceles trapezoid. But it's saying the same thing as it did in isosceles triangles. The base angles. So if this is one of your bases, and we've already talked about this, but if this is one of your bases, this angle and this angle have to be congruent. The only difference between this and triangles is that you also have base angles up here. Okay, so those angles would also be congruent. Again, we've already pointed all of that out, but just so you know, this is the trapezoid version of it-bat. Okay, that if you have an isosceles trapezoid, it has to be an isosceles trapezoid. Okay, but if you have an isosceles trapezoid, you've got congruent angles and congruent angles. Okay. All right, we've labored. Move on. Yay, approve.
It's been so long.
It has been.
Can we not?
Okay, no, we can. All right, so I am telling you this is a trapezoid, okay?
Are you sure?
I am sure. Because I know AB is parallel to CD, so I'm going to go ahead and mark that right away. AB is parallel to CD. And then this just says AD has been extended. So sometimes they tell you that in the given, sometimes they don't. Really, they just took this side and made it longer. Okay? And I want you to prove that angle 1 is supplementary to angle D. Okay?
We have to write all that.
What I would write for your, I mean, normally yes, but since this is your notes and it's going to be tiny, we don't have to worry about it. I want you to know that ABCD, well, let's just write that AB is parallel to CD. Because if I know that, then I know I have a trapezoid, right? So that's my given. I'll leave it alone. Look at my next step. It says angle 1 and angle 2 added together equal 180. Why do I know that? Caleb?
Because it's a line.
Okay.
And then it's cut in half basically.
You are right. Do you remember, does anyone remember what that's called? Jake?
Linear pair.
Linear pair, there you go. So this is linear pair theorem. Nice job. Okay, so I know 1 and 2 are equal to 180. What do I know about angle 2 and angle D?
Not greedy.
Matt?
They're corresponding.
They're corresponding angles, right? So they have to be congruent, yep. So for my step 2, I'm going to say angle 2 has to equal angle D by the corresponding angles postulate. I don't remember if I gave you proofs to do in your homework tonight or not. You may have. Okay. So look at what I have here. I have that angle 1 plus angle 2 is equal to 180. And I know angle 2 is equal to angle D. So I don't know if we've actually talked about what this is called in a proof, but I wonder if you can kind of reason it out. Why could I then jump to 1 plus D is equal to 180? If 1 plus 2 is 180 and 2 is equal to D. Caleb.
Because it's just like sliding D over where 2 is. And
Okay.
1 is the other half of the angle.
Love the way you said that. Okay. You said we slid 1 into like the other one's spot. And we're allowed to do that because they're equal to each other. That is called substitution. Okay. You can use that as a rationale in a proof. And I don't think we've had to do that yet, but.
No. No, we have not.
All right, well now you have. So substitution is if I tell you this is equal to this, that means those two things are interchangeable. So you could go back up here and say, oh, instead of angle 2, I want that to say angle D because that's what I'm trying to prove. Okay, so I use substitution there. So if I know 1 plus D is 180, how do I now know that they are supplementary?
Alternate.
Not quite that hard.
Yeah, something.
There you go. Oh, it's in there.
Yeah.
Duh.
Oh, I got.
Oh, I'm so smart.
It's right in the.
Silly me. Yeah, if I know the two things add up to 180, isn't that what it means to be supplementary? Right? So then I would say that's by definition of supplementary. Okay? So really that was just me proving what we had already talked about, that these two angles have to be congruent to one another. Okay? Just wanted you to get to see a proof again. Oh, it's okay. Sometimes it's you. So, okay. So in the trapezoid below, I know AB is parallel to CD. So I know this is parallel to this. Angle C is 118. So right now I'm just marking what the problem gives me. Find the measures of as many other angles as you can. Caleb, go ahead.
Well, you know that since you know that AV and CD are parallel, wait, does that mean it's giving us that it's an isosceles trapezoid?
No, and that's a really good point. Okay? We know two sides are parallel, so all we have here is a trapezoid. Does it look like an isosceles trapezoid? Sure, it does. Okay? But we don't know that for sure. So the only thing we can find is this angle B. How could I find angle B? Matt, go ahead.
Subtract 180.
Yeah, we know these two have to be supplementary, so I can do 180 minus, whoops, thank you, 180 minus 118, and so we get 62 degrees. Now, if this told us that this was an isosceles trapezoid, which I'm glad Caleb pointed that out, I could take these two angle measures and just put them here and here, right? But because it doesn't tell us that it's isosceles, I can't do that. Okay, it would have to tell us that. Bryce?
If you did do 118 and 118, would the others be 62 then still?
That's right. So this would be 118, 118, and then this would be 62, 62. Okay? Okay, GHJK is an isosceles trapezoid, so there's what we were looking for before. And then it said bases GH and JK. Why do they tell you which two are the bases? Jackson.
Because
They think that you don't assume things from the picture that you're not supposed to assume,
Yes.
right, Laura?
The bases are parallel.
Right. So I need to know which two are the bases, so I know which two I'm supposed to treat as the parallel sides. Okay? Now, Jackson, I think you said that way because you're looking at the picture and going, well, of course those two are parallel. But you can't assume that, right? You can't assume that from the picture. All right? So it has to tell you. Otherwise, you don't know. Jackson?
If they told us that GK and HJ are parallel,
You'd have to believe them.
like if they drew a circle and told us it was a trapezoid.
Well, they couldn't do that because you would still have to have segments. Okay? But I could draw. Well, that one does kind of look like a trapezoid. Never mind. I could draw
Draw a concave kite.
That looks like one too.
That looks like one
Draw a
too.
concave
Gosh,
kite.
You are
I
not
can't do
good
that.
at trying to not draw.
I know. I want to draw something that's not a trapezoid.
Try drawing or something. Anyways, do rainbow.
Yeah.
What are you trying to say, Marty?
Yep, you should, what?
There we go.
Like a trapeze.
Okay. If I tell you, yeah, but which two are parallel? Touche.
None of them because
Okay.
they don't have them.
But if I tell you these two are parallel, you have to believe me. Told you. That's why I get to keep my job as a geometry teacher, is because you have to believe the drawings that I
don't
create.
believe
Okay?
Although the X's do look like trapezoids.
Wait, I have.
All right. Go ahead, Caleb. What were we going to say?
Never mind.
Okay. So let's go back to the example. Sorry, we've lingered too long here. HJ is 31.8. So this is 31.8 over here. And angle H is 19 degrees. So this is 19 degrees. It says find as many other lengths and measures as possible. Okay, somebody raise your hand and tell me something we know. Jake, go ahead.
Wouldn't G be 19?
You're right. G would be 19 also, because this time this is an isosceles trapezoid. Okay, what else can we find? Caleb? Okay, you let me know if you remember it. Okay, Abby?
Because GH and KJ are parallel, that it would bisect it, so you could subtract 19 degrees out of 180.
Mm-hmm.
Supplementary, and then K would also be with J.
Good. So let's see, 180 minus 19 would be 161, is that right? And so Abby's absolutely right, you can make both of these 161. One more thing. Caleb, go ahead.
GK is length is 31.8.
31.8 also, yep, because in an isosceles trapezoid, these two have to be equal. Do I have any information that would get me the length of GH or KJ? No, but I can get everything else. Okay? Feeling good about trapezoids? I hope? Okay.